Hi, the phrase Cartesian plane is just a fancy word for the x and y axis. The x-axis runs horizontally and the y-axis runs vertically. As we have seen in geometry, the origin is where the x and y axes cross, and we call this O. We can mark it with a black dot over here. The origin has coordinates 0, 0. X values are negative on the left side of the origin and positive on the right. Y values are positive above the origin and negative below. If you are not familiar with the Cartesian plane, please go and watch our videos in the geometry section. Let's make some space. The Cartesian plane is made up of 4 quadrants. Quadrant 1, 2, 3, and 4. And each quadrant takes up a total of 90 degrees. When drawing an angle, we start at the origin and draw a straight line in any direction on the Cartesian plane. This line is known as the terminal arm. Then we draw an angle from the x-axis on the right side of the origin up to our terminal arm. Let's start by drawing our terminal arm along the x-axis. Because this line lies on the axis, we have an angle of 0 degrees. Moving up towards the y-axis, we now have 90 degrees. As we carry on back down toward the x-axis, we have another 90 degrees, which gives us 180 degrees. Moving down past the x-axis, back to the y-axis, gives us another 90 degrees, and we have 270 degrees. Finally, we can move back up to the x-axis where we started, and we have a final 90 degrees, which leads us to a total of 360 degrees. When drawing any angle, we start on the x-axis and we move in an anti-clockwise direction. Now I'd like to look at acute angles. So let's make some space and redraw our Cartesian plane so we can focus only on quadrant 1. Please remember that an acute angle is smaller than 90 degrees, so our angle will always lie somewhere in the first quadrant. Let's draw a line over here. We measure our angle from the x-axis up to this line, which we call the terminal arm. Please remember that these drawings are not to scale. You do not have to use a protractor or measure the exact angle. If you are asked to draw an acute angle, all you have to do is draw the terminal arm from the origin into the first quadrant. We have just said that when working with angles in the Cartesian plane, we start on the x-axis and we draw an angle up to the terminal arm. Let's call our angle theta. Now, we know from coordinate geometry that any point on the Cartesian plane has an x-coordinate and a y-coordinate. The x-coordinate tells us the distance of the point from the y-axis parallel to the x-axis, and the y-coordinate tells us the distance of the point from the x-axis parallel to the y-axis. So let's draw a point on our terminal arm and call it P. Point P will have an x-coordinate and a y-coordinate. We have just said the x-coordinate shows the distance of the point from the y-axis. So let's draw a line from the y-axis to the point P. This line is parallel to the x-axis. The y-coordinate shows us the distance of point P from the x-axis. So let's draw a line from P down to the x-axis. This line is parallel to the y-axis. Our horizontal green line runs from the left to right, parallel to the x-axis. So let's move it down and put it on top of the x-axis. Now we can see that the value of our x-coordinate is the distance from the origin to the point where this vertical line over here touches the x-axis. So the length of this line must be x. Also, we can see the y-coordinate is the distance between point P and the x-axis. So the length of this line must be y. Now the horizontal line runs along the x-axis and the vertical line runs parallel to the y-axis. We know that the x and y axes are perpendicular to each other, which means that these lines are perpendicular as well. They are at a 90-degree angle to each other. So let's put a 90-degree angle in over here. Let's make some space so we can focus on our triangle. Now we have a right angle triangle with a 90-degree angle and an acute angle theta. The side of the triangle directly opposite to the 90-degree angle is the hypotenuse. So in this case, our terminal arm is the hypotenuse of the triangle. So let's write an H over here. Earlier, we said that when drawing an angle in the Cartesian plane, we always start on the x-axis and draw up to the terminal arm in an anti-clockwise direction. So from this, we can see that angle theta will always sit over here, right next to the origin. Our vertical line y is always directly opposite from theta. So let's put in an O for opposite over here. Our horizontal line, the third side of our triangle, is always adjacent to theta. So let's put in an A over here. When working with trigonometry in the Cartesian plane, we call the hypotenuse of the triangle the terminal arm. And instead of calling it H, we now call it R. When we looked at trigonometry and right angle triangles, we worked with the hypotenuse H, the opposite side O, and the adjacent side A. But now, when working with the Cartesian plane, we now call the hypotenuse R, the opposite side of the triangle is now Y, and the adjacent side is now X. With this information, let's look at our sine, cos, and tan ratios. We have used SOHCAHTOA and learned that sine theta is equal to the opposite side over the hypotenuse. Cos theta is equal to the adjacent side over the hypotenuse. And tan theta is equal to the opposite over the adjacent side. Now we can use x, y, and r to find our new ratios. So we can say sine theta is equal to our opposite side, which is now y, over the hypotenuse, which is now r. For cos theta, it is now equal to the adjacent side, which we now call x, over the hypotenuse, which is now r. For tan theta, it is now equal to the opposite side, which is y, over the adjacent side, x. In our previous videos, we also learned about reciprocal ratios. We learned that cosec theta is equal to the hypotenuse over the opposite side. Sec theta is equal to the hypotenuse over the adjacent side. And cot theta is equal to the adjacent side over the opposite side. Cosec theta is equal to the hypotenuse over the opposite side. Now the hypotenuse is r and the opposite side is y. So when working with the Cartesian plane, we see that cosec theta is equal to r over y. We know that sec theta is equal to the hypotenuse over the adjacent side. Now the hypotenuse is r and the adjacent side is x. And we see that sec theta is equal to r over x. Finally, we know that cot theta is equal to the adjacent side over the opposite side. Now the adjacent side is x and the opposite side is y. So we see that cot theta is equal to x over y. Let's make some space. In our earlier videos, we learned that when working with right angle triangles, we can use Pythagoras to find the length of an unknown side. We learned that if we need to find the length of the hypotenuse, we can use the theorem h for hypotenuse is equal to one side, let's say the adjacent side, squared, plus the opposite side squared, all under a square root. We also learned that if we have the length of the hypotenuse, we can find an unknown side, such as the opposite side. So for example, we can say O is equal to the hypotenuse squared minus the length of the adjacent side squared, all under a square root. We are still working with a right angle triangle, so we can still use Pythagoras to find unknown sides. Our hypotenuse is now known as r. So to find the length of the hypotenuse, we say r is equal to one side, let's call it x, squared, plus our other known side, y, squared, all under a square root. If we know the value of the hypotenuse, which in this case is r, we can still find the value of the unknown side. Let's say we need to find the length of the opposite side. So we can now say the opposite side, which is y, is equal to the length of the hypotenuse, which is now r, squared, minus the length of the known side, x, squared, all under a square root. We can also still use Pythagoras to find the adjacent side by making x the subject of the equation. We have used this triangle to help explain how trigonometric ratios work in the Cartesian plane. Please remember that when working with these ratios, x will always be the value of the x-coordinate of the given point, and y will always be the y-coordinate of the given point, regardless of where the point lies on the Cartesian plane. As long as you are given two values, you can use Pythagoras to find the unknown. Now that we have this basic information, let's look at some examples of how we work with this. Calculate x, y, or r in the following. For part A, we have a diagram with an acute angle in the first quadrant. We have point P, 5y, and r is 13, the length of our terminal arm. And in this case, we need to solve for y. Our terminal arm is 13 units. So let's make a note, and we say r is 13. Our x-coordinate is 5, so we can make a note of this as well, and we say x is equal to 5. Now we need to find the value of y, and we can use Pythagoras. So we're going to say y is equal to r squared minus x squared, all under square root. And now we can fill in our values. R is 13, so we can say 13 squared minus the value of x, which is 5, squared, all under a square root. Now we can take our calculator and we say 13 squared minus 5 squared is equal to, let's square root our answer, and we get a value of 12. So in this case, y is equal to 12. Let's do another example. Again, we have an acute angle. We have point 43, and we need to find the unknown value of r. Our x-coordinate is 4, so we can make a note and say x equal to 4. Our y-coordinate is 3, so we can say y is equal to 3. Now to find r, we say r is equal to x squared plus y squared, all under square root. Now we can fill in our values. X is 4, so we say 4 squared plus the value of y, which is 3 squared, all under square root. Take our calculator. We say 4 squared plus 3 squared is equal to, let's square root our answer, and we get an answer of 5. This is the value of r. Now let's look at an example that considers angles as well. Use the diagram below to determine 1, the value of x, 2, cos theta, and 3, tan theta. Let's start with part 1. In our diagram, we can see that the length of the terminal arm is 5 units. This is our r value. We can say r is equal to 5. The y-coordinate of point P is 4. So we can say y is equal to 4. Now we can use Pythagoras to solve for x. So we can say x is equal to r squared minus y squared under a square root. Now we can fill in our values. R is 5, so we say 5 squared minus the value of y, 4 squared, all under a square root. Let's take our calculator. We say 5 squared minus 4 squared. Square root our answer. And we get a value of 3. This is our x value. Let's make a note of it up here, clean up our page, and move on to part 2. Determine cos theta. Now, earlier in this video, we found that when working with the Cartesian plane, cos theta is equal to x over r. The question tells us that r is 5, and we've just found that x is 3. So now we can say cos and our angle theta is equal to the value of x, which is 3, over the value of r, which is 5. Let's tidy this up and move on to part 3. Determine tan theta. We've also found that tan theta is equal to y over x. We know that y is 4 and x is 3. So now we can say tan theta is equal to y, which is 4, over x, which is 3. Let's do one more example. Use the diagram below to determine the value of r, sine theta, and tan theta. Let's start with part 1. Here we need to find the value of r. Let's look at our x and y values first. Point P has coordinates 8 and 15. The x coordinate of 8 takes on our x value, so we can say x is equal to 8. And the y coordinate, 15, is our y value, so we say y is equal to 15. Now we can solve for r. So we can say r is equal to x squared plus y squared, all under a square root. Now we can fill in our values. X is 8, so we have 8 squared plus the value of y, 15 squared, all under a square root. Now we can take our calculator. We say 8 squared plus 15 squared is equal to, let's square root our answer, and we get 17. This is the value of r. Let's make a note of this over here, tidy up our page, and now we can move on to part 2. Determine sine theta. We know that sine theta is equal to y over r. The question tells us that y is 15, and we've just found out that r is 17. So now we can say sine theta is equal to y, which is 15, over r, which is 17. Finally, let's clear this up and move on to part 3. Determine tan theta. We know that tan theta is equal to y over x. In this case, y is 15 and x is 8. So now we can say tan theta is equal to the value of y, 15, over the value of x, which is 8. And we have now completed this question.